friends, Dr. May here. I've been getting a lot of questions about the hot topics for this unit on symmetry and transformations. So I thought we'd take a look at the top 3 topics, and I hope this helps you as you get ready for your test.
All right, let's begin with our first topic, and that is rotational symmetry. So the first question, if we look at this figure, it is a nonagon, and you can count the number of sides. There are 9 sides here, okay? The question says, is it a regular polygon? So let's remember what regular polygons are. A regular polygon is a polygon which all the sides are the same. You can see that our nonagon here is our 9-sided figure. Again, all of the sides are the same. So yes, this one is a regular polygon. Now the question is, what is the angle of rotation for a nonagon? So here's what we're trying to do. I want to rotate this nonagon so that it will produce an image that is the same as the pre-image. So what I'm going to use is my slider here. So if I rotate 10, you see that the red nonagon is different than the green. So I haven't got it back to look just like the original. Let's go to 20 degrees. Again, the red and the green are not the same. 30 degrees, not the same. And there it is, 40 degrees. So my angle of rotation is 40 degrees. So let's keep going. 50 doesn't work, 60 doesn't work, 70 doesn't work, but 80 does. So I want you to see that we got an angle of rotation of 40, 80. I bet you're guessing the pattern now, right? Not 90, not 100, not 110, 120. So look at our pattern. We've got 40, 80, 120. I bet you can see the pattern now. 160, 200, 240, 280, and so forth, 320, okay? All of those multiples of 40 are angles of rotation for this nonagon. So I bet you're asking, Dr. May, is there a rule, a formula I can remember? And the answer is yes. If you want to find the angle of rotation for a regular polygon, you would take 360 divided by the number of sides. So you see my hexagon here has 6 sides, and I would do 360 divided by 6 in order to see that that angle of rotation is 60, but don't forget, it's all the multiples of 60 as well. So it's 60, 120, 180, 240, and 300. Okay, let's take a look at another topic. For our next topic that I want to look at is to do 2 transformations. So let's read this problem. It says point A has the coordinates of -3, 2. So let's draw that. -3, 2 would be over here in quadrant 2. Okay? And then it's transformed by the translation x plus 3, y minus 4. So x plus 3 means to go right 3. Let's choose a different color now. So we're going to go right 3, 1, 2, 3, and we're going to go down 4, 1, 2, 3, 4. And so this is A prime. And let me go ahead and label the blue one as A. All right. Next, notice the statement says, then A prime is transformed by the rule x plus 5, y minus 3 to produce a double prime. So let me grab the green. So now we're going right 5, 1, 2, 3, 4, 5, and down 3, 1, 2, 3. And again, this is a double prime. Okay, now look at the question. It says, which quadrant will the final image a double prime be in? And what would the rule be for the composition transformation? So the quadrant's pretty easy to see. Notice we have quadrant 1, quadrant 2, quadrant 3, and so a double prime lands in quadrant 4. Okay? And then what we want to know is, okay, how do I get from A to a double prime? So I would have to go right 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go right 8 and down 1, 2, 3, 4, 5, 6, 7. So if I want to write the composition transformation, so that's xy takes me to x plus 8 and y minus 7. And forgive me with my writing here, but that is this answer choice, okay? So really think about, you're doing two transformations and then you're asking yourself, okay, how do I get from the original pre-image to the last image, the double prime there? All right, for our last topic to get you ready for the Unit 4 test, I want to look at having multiple transformations and being able to describe them. I find sometimes that students have a little bit of difficulty recognizing some of them, so let's see if we can put them together. I'm going to show you the first transformation. So notice that we rotated, and we rotated 90 degrees clockwise. Do you need to say the 90 degrees clockwise? Yes. Okay, so you want to be specific to tell us the direction, either clockwise or counterclockwise, and then also tell the angle. So your first transformation here was to rotate clockwise 90 degrees. So let's look at the second one. And that one is a translation, right? We're looking at that red triangle is a translation up 1. And then finally, we get a reflection. So let's see how we would do that. We would say rotate 90 degrees clockwise. Then we went translate up 1. And then finally, we reflect about the y-axis. So make sure that when you tell us a reflection, that you tell us the axis for which you are rotating about.
All right, friends, that's all I have for you. Those top 3 topics to get you ready for this unit test over transformations. I'm wishing you all the best. Do your very best. I'm proud of you. Bye for now.